add the exponents. Remember that when we do exponents, this is the base. So here's the base, and here's the exponent. So the rule here they give us is x to the power of m times x to the power of n equals x to the power of m plus n. So what the heck does this mean? So let's look at an example of what multiplying exponents looks like. So here we have 2 to the 6th times 2 to the 3rd. So when we multiply these two terms together, when I say terms, I mean this term and this term. When we multiply those two, we add the exponents. We can only add the exponents because they have the same base. What is the base on these two powers here? 2. Base is 2. So because both terms have a base of 2, we can add the exponent. So 2 to the 6th times 2 to the 3rd equals 2 to the power of 6 plus 3. And what is 6 plus 3? 9. So 2 times this 2 to the power of 6 times 2 to the power of 3 equals 2 to the power of 9. And if you went to your calculator and you tried that, if you went to 2 caret 9, that would give you 512. So let's try some examples together. So I'm going to show you some examples of things that will work, and then we'll get to some examples of things that won't work. So 3 squared times 3 squared, or 3 to the power of 2 times 3 to the power of 2. So what I'm doing is that because I have a base of 3 in both of these, I'm adding the exponents. So 2 plus 2 is what? 4. So this is 3 to the power of 4. And I'm not going to calculate the answers right now. I just want to show you guys how to combine them. 5 to the power of 2 times 5 to the power of 4. Again, I'm adding the exponents. So 2 plus 4 is 6. So this is 5 to the power of 6. And here's our first example with some letters, but don't let the letters scare you away. A to the power of 5 times a to the power of 2. Again, we just add the exponents. So this becomes a to what power? 7, yep. Questions so far about those first three? Okay, let's keep going. This one has a couple things going on. So let's figure out what the heck's going on. So we have 2 times s to the power of 2 times 4 times s to the power of 7. So one thing that they might not have taught you in math lab is that when you see two things right next to each other, that means there's already multiplication going on. So for example, I'm just going to write a side note up here. If you see something like 2 times x, this is the same thing as saying, if you see 2x, that's the same thing as saying 2 times x. The reason I'm telling you that is because when I see number 4 right here, that's saying to multiply everything together. Now, because I don't know what s is, I can't multiply s and 2, because since I don't know what s is, I don't know what the answer would be. But I know how to multiply numbers together. So 2 times 4 would be what? 8, right? Now I can multiply my s's together. So I have s to the 2nd power, s to the 7th power, and again, I'm just adding the exponents together. So what would those two things multiplied be? So remember, say it again. Remember I'm adding. So multiplying, exactly, yeah. So s to the 2nd times s to the 7th is s to the 9th. So yeah, so that would be my final answer on this one is 8 times s to the 9th. So remember, when I multiply numbers with exponents, I add the exponents. Yeah, 7 plus 2. Yes. Yeah, the letter is, yeah, exactly. The letter is the placeholder. It's going to stay the same, right? Okay. Okay, number 5 is a little bit easier. I have negative 3 to the power of 2 times negative 3 to the power of 3. Does anybody know what that would be? Let's not. We're just going to keep. We're not going to calculate. We're just going to do the. We're just combining the exponents right now. Okay. Yeah, negative 3 to the power of 5. Because when we multiply numbers with exponents, we add the exponents. So that's negative 3 to the power of 5. Okay, number 6 looks a little bit tricky. But let's just work through it step by step. So we got s's and we got t's. So we have s to the power of 2 times s to the power of 7. So again, when we multiply numbers with exponents, we add the exponents. So we have 2 and we have 7. What's 7 plus 2? Yeah, s to the 9. And t7 because we have t to the power of 4 times t to the power of 3. So it would be t to the power of 7. 4 plus 3 is 7. Sure, I can write that out. Yep. Let's see here. Yeah, no problem. So yeah, we have s to the power of 2 plus 7 times t to the power of 4 plus 3. Oh, yeah. Oh, I'm sorry, I messed up. Hang on. Oh, no, I didn't. That's fine. That's good. Yes. So what we're doing here is we're multiplying like terms. So these two, I think you're talking about this 2 and this 4, right? So yeah, you do not combine exponents because these are different bases. We're only combining similar bases together. So if I want to rewrite this a little bit to make it look a little bit easier, I could have wrote it like this. I could have said another way. Easy way to look at it would be s squared times s7 times t4 times t3. I could write it like that. That way, I have all the like stuff together. I would have gotten the same thing. Okay, so now that I showed you some stuff that you are allowed to do, can I show you some stuff that you're not allowed to do? So here's some stuff you're not allowed to do. So if I have, let's just say I had 2 to the 3rd power plus 3 to the 3rd power. Would I be able to combine those exponents? No, because I have different bases. So the bases are different. So what I cannot do is I can't say, oh, that's a 5 to the 8 or 6 or whatever. That's something I cannot do. Same thing if you had like, oh, actually, yeah, I'm going to say multiply. Also, if I had something like addition, so if I had, I'm going to use some letters actually. If I had x to the 2nd plus x to the 4th, remember this rule is only if you multiply. This is a multiplication rule. So this does not work for addition. So this would not work. So remember the rule is when you multiply numbers, you add the exponents. Yes. Yeah, base, keep the base. Yes. So when you multiply numbers, you add the exponents. Any questions about the multiplication rule? Okay, so the next rule is about division. So if you multiply numbers and you add the exponents, you divide numbers, what do you think you do with the exponents? Subtract, right? Multiplication and division are opposites, and so is addition and subtraction. So this is the next page here. So when dividing numbers with exponents, you subtract the exponents. So I'm going to write these out a little bit differently so they make a little more sense. But let's just look at the first example here. Here we have 2 to the 6th power divided by 2 to the 2nd power. And look what they did. They said 2 to the 6th minus 2 is 2 to the 4th power. And let me show you, do I have any room here? Let me show you why this works. I'm completely out of paper. So the reason this works, I'm going to rewrite what they have here. 2 to the 6th divided by 2 to the 2nd. Do you guys remember when we wrote out the exponents, like 2 to the 6th power is the same as saying 2 times 2 times 2 times 2 times 2 times 2? You remember when we did that? And 2 to the 2nd is the same as saying 2 times 2. If you remember anything about fractions, you know that this can cancel. So all I'm left with is 2 times 2 times 2 times 2, which is the same as 2 to the 4th. So if that's too hard to remember, don't worry, but that's why this division stuff works. So let's look at the examples. Starting with number 7 here. So this says s to the 12th divided by s to the 4th. And I'm going to rewrite this a little bit. So we have s to the 12th power divided by s to the 4th. That way, I think it might be easier to see the subtraction that way. So remember, when you divide numbers, you subtract exponents. So what is 12 minus 4? 8. Oops. So s to the 12th divided by s to the 4th is s to the 8th. Huh? 3 is okay. Yeah, what you're doing is you're dividing. But remember, when we have exponents, you don't. When you do division, the exponents get subtracted. Exponents are different than regular numbers. Okay, let's try the next one. Somebody besides Jermaine, because Jermaine's spouting out lots of answers over here. It's not fair, right? It's not fair. Okay, so we got 3 to the 9th divided by 3 to the 5th. Division means we subtract exponents, so what is 9 minus 5? Yep, so this becomes 3 to the 4th. No, it's not bad at all. Okay, so number 9. Oh boy. Number 9. Woo. Right here? On number 7 or number 8? That's an 8. Oh, that's an S. That's an S. Yeah, I'm sorry. My S's do look like 5s, don't they? That's a scribble. I messed up. Okay. You want to try number 9? Okay. I'll give you guys a second. Here, I'll pause my screen. That's what I'll do. Oops. No, it's fine. 8 and 4, yep. That's what I got. So the first thing that I did is I just rewrote everything. So this is how I rewrote the problem. So I rewrote it as say s to the 12th times t to the 8th divided by s to the 4th times t to the 4th. So remember, so we got s to the 12th. Then I need to subtract the exponent from the other s. So 12 minus 4 is 8. 12 minus 4 is 8. And then do the t's. So t to the 8th and t to the 4th. 8 minus 4 is 4.
Then what was the T right there? No, we don't put the minus.
So I wrote everything out. That's good for the s's. But then you got to do the t's too.
Okay.
If that's confusing, you could also. Show you another way to do that. Let me show you another way to do this. I'll wait till they finish talking. So one thing I could do, here's the same problem I just rewrote on this piece of paper here. I'll cover up this. What I could do is I could split this into two different fractions. So here's one fraction right there. And here's one fraction right here. So if it's easier to look at it as two separate problems, that way I could do this problem s to the 12th divided by s to the 4th. And then I would have, is my orange showing up? Yep. T to the 8th divided by t to the 4th. And then just solve those problems separately. So 12 minus 4 is 8. This would be s to the 8th. And then here 8 minus 4 is 4. And then just remember that I had to multiply these two back together. When I multiply those two, since I can't multiply s and t because they're not like terms. Oh, sorry, it's blurry. Woo! Woo! Come on. There we go. I know, right? Come on. I know, I see it. I can see what you guys are seeing. There we go. And then I just put them back together. S to the 8th, t to the 4th. You can do the same thing for 10, yep. Well, okay, so, but with numbers, like 36 divided by 4, that's something that we can do. Are you talking about number 10? Yeah. So here, let me... I have my screen frozen if you guys want to try number 10. I'm going to split number 10 into 3 problems. I think it might just look easier that way. Here, I'll unfreeze my screen. So if I split number 10 into 3 separate problems, so I have 36 divided by 4, And I have a to the fifth divided by a to the fourth. Oops, a, not 8, a to the fourth. And b to the eighth divided by b to the fifth. Yeah, so you basically do what I'm doing, but you're just not doing the step, which is okay. Yeah, you can do it like that. So 36 divided by 4 is what, guys? 9, yep. If you don't know that, you can look at the multiplication table or do it on a calculator. A to the fifth divided by a to the fourth. I'm subtracting the exponents, so what's 5 minus 4? 1. B to the eighth divided by b to the fifth would be what? 3. B to the 3, yep. And there we go, that would be our answer right there. Now, when I have anything to the first... So, Fanita, I am kind of Fanita, I am kind of rushing just so I can get past this page. Sure, yeah, sure. So let me say one thing, and before you do that, Jermaine, let me say one thing is that when you have anything to the first power, it's just itself. So really, I wouldn't write it like that. I would write it as 9a times b to the third. Because remember, anything to the first power is just itself. 1 to the first power is 1, 100 to the first power is 100, a to the first power is just a. Okay. Any questions on those 4 or either one of those rules? I was going to have you guys start on practice, but we're kind of out of time on that. I'm going to stop the video.